I'm here at CES 2026, where I'm about to get a private tour of Ceva's suite. It is awesome in here. They've got 3 main pillars, and I want to find out something about each of them. Connect, Infer, and Sense. Probably not in that order. Let's go knock. Hey, how's it going?
Hey, it's going. Good seeing you again. How's it going?
Good, good, good. I got a booking with Ceva. I want to talk about what you're going on over here, right?
Wow. Okay.
What is new with Ceva? And then we're going to go and have a look at your whole suite of demos.
Perfect. We're here at CES today talking about physical AI and how we enable it as a company in providing the capabilities to our customer. What we believe that in order to have physical AI really work, you need to have 3 major use cases. You need to have the ability to connect across multiple protocols. You want to have sense, meaning perception layer, understanding what's happening in the environment around you. Audio, video, information, and then infer it so it can actually create value. This is where the magic will happen. As you can see, we have already multiple devices supported by Ceva, and we're actually shipping we shipped more than 20 billion devices to date. It's around 60 devices per second coming out based on Ceva technology. Why don't I take you and show you the wireless connectivity demo? First one, wireless connectivity is our foundation. This is the base layer allowing every device to connect not only with the cloud, but between multiple devices. Franz here will show you a little bit more about what we're doing around UWB or whatever.
Franz.
Hey, nice to see you.
Tell me, what's going on over here?
Okay, very good. So we are part of the Connect. So here he was mentioning Connect, Sense, Infer, so that's Connect. And here I'm going to show you 2 demos. First one is our Bluetooth solutions, compatible with the next generation of Bluetooth, supporting high data throughput, up to 7.5 megabits per second. So here we have basically a receiver, audio receiver, so which is receiving audio from this charging case. So this charging case is actually compatible with Bluetooth Auracast, which is a new way of transmitting audio over the air. And so we can hear the audio on the earbud for sure. So which is the earbud for the charging case. And also on this on this board, so I have connected the headset on this board here, so you can also hear the audio.
I'll verify this. Yeah, that's funky.
Yeah. And so with Bluetooth high data throughput, so next generation, you will be able to stream high quality, high resolution, multi-channel, lossless audio, basically. So for basically home cinema type of devices, etc.
Very cool.
Very high quality.
So we've got high quality audio receiving over here. Yeah. What have we got over here?
So here, this is a ultra wideband. So we are actually demonstrating ranging. So ultra wideband is all about, that's the main application. So ranging to measure the distance between, for instance, this phone and a peer device. So here you have a dongle with a chip from one of our customers with our UWB technology. And we are just measuring the distance between this phone, so which is a Samsung Galaxy phone, and to this dongle. So
how accurate are we? We've got 70, 82-ish there?
It's a few centimeters accuracy, basically. Main application are car access and smart access in general, so to open a door or to trigger any action. For instance, if it is on a laptop, you can use that to automatically log on or log off when you step away from your laptop, so it will automatically log off the laptop and log on again when you come back. So that's part of the main application you can do with UWB.
Very cool. Thanks very much, Franz.
Thanks.
The next use case we're very much focused on is sensing. That's the perception layer, what allows you actually to understand what's happening around you, if it's visual, if it's audio, if it's information coming in or coming out, which is a very critical information because that's what will allow you actually to make decisions. I'll allow to Brian give you a little bit of a quick demo about what we've been doing here.
So I've had Connect, now it's time for Sense. So I've just come from the Connect section, now it's time for Sensing. Right?
All right, let's do it.
Oh, damn. So what do we got over here?
So we have a pointing remote, and we've been able to integrate the same ultra wideband that we were using over there.
Beautiful.
To allow us to not only know the distance from the TV, but also the angles of the remote relative to the TV.
Okay.
So you can do several interesting things with it. One is for your cursor on the screen, you can be more of an absolute pointer so that it knows when you're pointing away from the screen and when you're pointing onto the screen.
Yeah, so before, when you used to have this remote, you'd point over here, and then when it gets to the left, it gets stuck, and you move it further, and then it's completely out of calibration.
Yeah, so the relative pointer just like your desktop mouse.
Okay,
You can
beautiful.
use it comfortably wherever you want it, but it's not relative to the screen.
Okay.
This one it become an absolute pointer, so it can point where you're pointing on the screen is where it's going to point.
So what software from Ceva is actually in this product?
We have a software called Motion Engine Hex, which uses the inertial sensing processing to use the gyroscope and accelerometer that's needed for relative pointing, and fuse that with any ultra-wideband provider to give yourself the absolute pointing.
Brilliant. We haven't got enough time to go through all of this, but if you're more interested, I'm sure you'd be happy to tell more people about it. All right, I've seen Connect.
Yeah.
I've seen Sense. It's time for Inference.
Let's go for Inference.
Let's
So
do it.
Inference is where you actually monetize all the investment you've had about training models.
Say monetize.
Yeah, monetizing because you want to create value. People are actually going to take action, making decisions. So you connected, you understand the environment, you get new models.
Yes.
You understand what's happening around you.
You're
Now you
sensing
want to
it.
actually, now you actually want to do something.
Do something with that data, yeah.
And for that, need to have models. So first of all, one thing we want to show here is our model, a model zoo, or a library of models that we're participating with the industry, building them. They're pre-optimized to our hardware, allowing customer to take them and deploy them in a really fast way.
Yeah,
and we have
very
a variety of models. Another one is SLM, which you're probably familiar with large language models.
Yes, but
This
SLM.
SLM is small language model.
Oh, okay,
Much
convenient.
smaller, but you can run it on a much smaller devices. You don't have to get a PC or a full mobile phone. You can run it. So, for example, this is something that actually writes tiny stories. So let's write something around Ceva booth at CES. Ceva booth at CES. Two people, Joe and Jack, were there. They're just creating a kid story
Joe
in
and
real
Jack?
time. Yeah. It's
Are
just
you
creating,
Joe?
no, I'm not Joe, but it's like taking the information and now you continue learning. So it's just taking the information and creating a story based on what I told you, based on the prompt. This is a kid
Wow.
story, yeah.
And what is this running on? Is this, you've
This
actually
is
got
run-
some silicon here running this?
Yeah, we have it running over here on this one. This is actually on an Ceva Nano, which is our smallest NPU. So we have a
Yeah.
variety of NPU going from very small to very large, all of them connected, so you can scale up or scale down running the same model. So
Brilliant.
what we believe is you need to have the right model, you run the right model at the right place at the right time, but you have to get the right NPU, the right agent for that. You don't want to have it overpower, and you don't want to have, overpower, taking too much power, but you don't have enough performance. So this is why we have a family of multiple NPUs that you can go and adjust, and all using the same software tools and capabilities.
Very cool.
That's in general.
I love a good spectrogram. Can we have a look at what's going on back here?
Yeah, sure.
Brilliant. So what is this? Is this audio enhancing that you've
Yeah,
got going
this is-
here? So what are we looking at here? I see we've got noisy and enhanced.
Yeah, so this is the noising model running on our hardware. So you see the difference. Over here it's very, very noisy, and after you start cleaning it up, you see how it's becoming much cleaner and improving the voice quality.
Yeah, brilliant.
We've seen that across. This is very similar to what we have on this device over here, which is actually a smart mic microphone. So you're running the model and everything on this. You don't have to take it to the cloud. And you're actually improving the voice quality and what you're speaking. Think about later on, you can actually add more capabilities, so enhancing it in real time. But as you can see, this is the original. This is after it's been denoised. Much better capabilities.
Very cool. So everything that we've seen here today is all running on Ceva IP.
Yeah, indeed.
If people want to come in here and check this out for themselves, if they're in Las Vegas this week, where can they find you?
Come here. We're the Venetian, Bassano 2709. We're going to be here till Friday night. Always open. Come and see and learn more about what we're doing.
Cool, awesome. Thanks very much for having me.
Yeah, no problem.